Okay, this is Algebra 1, Lesson 11.6. We're going to look at radical expressions today. Some of these things will be a little bit of a review for you guys. It's kind of pulling some stuff that we've looked at before, but then kind of bringing it all together. So let's start with our warm-up. It says to identify the perfect square in each set. So basically, what number is a perfect square of another number? So in this first set, the only one is 81, because 81 is the perfect square of 9 times 9. Okay, and then the second one, the perfect square is 25, because 25 is the square of 5 times 5. And this next one, you may not, some of these you might have to kind of start to memorize. It's actually 256. This is the perfect square of 16. And then for number 4, the perfect square is 196. This is a perfect square of 14. So I would suggest maybe kind of memorizing some of your perfect squares, especially up to 15. But if you can do maybe up to 20, that wouldn't be so bad either. So whatever you guys are able to do would be great. Okay, so the next part of the warm-up said to write each number as a product with one of the factors being the largest perfect square factor. Okay, so what it's trying to say here, this is a little tricky, is can you split this up into anything that has a perfect square within it? The way this is worded is a little weird. I'm actually going to just take the square root of these first 3 and then show you what I mean on the last one. So the perfect square of 36 square root is 6, which is 6 times 6. 64 is equal to 8 times 8. 196 we did is 14 times 14. Okay, now 24 is not a perfect square. But what I want you to do is I want you to think about the biggest perfect square that goes into 24. So your perfect squares are 4, 9, 16, 25, 36. Let's see, 7 times 7, we got 49, we've got 64. So basically these are your perfect squares. So of these, which is the biggest one that goes into 24? Well, the only one that goes into it evenly is the number 4, and we can break this up into 4 times 6. This is going to be helpful in this lesson. You really want to know all of your perfect squares. You want to have these memorized, especially these first few. You want to know that 4 is if I took the square root of 4, that would be 2. If I took the square root of 9, that would be 3. If I took the square root of 16, that would be 4. And so on. So you really want to know these perfect squares. This is something you want to know. So we're going to look at simplifying radical expressions, and then you're going to hear what a radical expression is, and then this word called a radicand. It's a nice new word for you. All right. So an expression that contains a radical sign, so we've seen this radical sign before, is a radical expression. There are many different types of radical expressions, but in this course, you will only study radical expressions that are square roots. So remember, even though it's not written here, we're assuming that there's a little 2 here because it's taking the square root, meaning 2, the second root. So all of these here are examples of radical expressions with a square root. Even though it's not written, if it's not written, we're assuming it's a square root, okay? The expression under a radical sign is the radicand. So all of these things under the radical are called the radicand. And a radicand can contain numbers, it can contain variables, or it might contain both. It may even contain one term or more than one term. For example, this has 2 terms here. This has numbers and variables. So just be aware that that can be in all these radicands. Okay, things we need to check off to make sure that a radical has been simplified as far as it possibly can go, meaning we can't go any further. We can't simplify it any further. We want to make sure that first and foremost, the radicand, meaning what's under the square root, has no other perfect square factors other than 1 that can go into it. And those perfect square factors are 4, 9, 16, 25, 36, 49, 64, and so on, okay? The ones that are perfect squares of numbers. We want to make sure the radicand has no fractions under it. And then we want to make sure there's never a square root in a denominator. If we have a fraction, that can never be in a denominator. Can I move this? Okay. All right, remember that positive numbers have 2 square roots. one positive, one negative. Okay, so like if I took the square root of 49, I told you guys we would write that as plus and minus 7. However, if you see the square root, that's indicating a non-negative square root. So when you simplify, you want to make sure that your answer isn't negative. So even though I said we do the plus and minus, in this case, we're not going to do the plus and minus, okay? We're actually going to, for example, if I were to simplify the square root of x squared, that's just x. But in order to say that it's only positive x's, we should use absolute value signs. So just to say that it's not, because we don't know if x is positive or negative. I'll show you some more of these in a second. Okay, so let's simplify these radicals here. All right, so I suggest, okay, when you come across a radical with a fraction, if you can, simplify the fraction first. So for example, can 2 over 50 be simplified? Well, 2 goes into 50, or 2 goes into 2 one time, and 2 goes into 50 25 times. So I can rewrite this as the square root of 1 over 25. And then that's the same thing as the square root of 1 over the square root of 25. The square root of 1 is 1, and the square root of 25 is 5. And again, we just need the positive answer for now. Okay, for this next one, we're going to do our, something I noticed you guys have been kind of forgetting is our PEMDAS. We want to take care of parentheses and exponents first. So if you see exponents, we should simplify this first. So 8 squared is 64, and 15 squared is 225. Now we can add those together, and we get the square root of 289. And the square root of 289 is 17. Okay? Now this next one's a little tricky. When you see a quadratic or a trinomial, what you want to do is you want to try to factor it, okay? And we're hoping that when we factor it, it makes a perfect square factor. So for example, if I factor x and x, I can make 9, 3, and 3, and I can have a minus sign in between. This means I can rewrite this as x minus 3 squared, because it's x minus 3 times x minus 3. And that makes that whole quantity go away. So my answer is just x minus 3. Okay? So I took the square root, so it takes away one of those x minus 3's. So just kind of an idea of this product property for any non-negative real numbers, a and b. So if I have non-negative numbers, that means they're positive. The square root of a and b is equal to the square root of a times the square root of b. All right? So just an example, if I have the square root of 4 times 25, that's the same thing as the square root of 100, which is 10. Or if I had the square root of 4 times 25, I could separate that into the square root of 4 and the square root of 25. And then I know the square root of 4 is 2 and the square root of 5, or 25 is 5. So now when I multiply those together, I get 10. So that's going to be helpful for these next ones that we're solving. Okay, so to simplify, what you want to do is you want to separate out the numbers into as many of the greatest perfect squares that you can. So remember those perfect squares I said? So 4, what am I thinking? 9, 16, 25, 36, 49, 64, and so on. We want to check, do any of these, what's the biggest one that goes into the number under the radical? So we could split 24 up into 4 times 6, because I know that 4 goes into it. And then I could separate the 4 and the 6, and the square root of 4 is 2, and then I just have the 6 left because it can't be simplified. So you're done, okay? Let me show you on this next one. Okay, so we know that we can rewrite 27 as the square root of 9 times the square root of 3, okay? With variables, there's a couple ways to think about this. Because we're taking the square root, we know there's a little 2 out there. So if I have the square root of x cubed, okay, so I've got a little 2 there, a little 2, and y to the 8th. So I basically just split all this stuff up. I can simplify the 9, okay, into 3. The square root of 9 is 3. I can't simplify my 3. square root of 3, so that stays. The square root of x cubed. When you have variables with exponents, what you want to do is you want to figure out how many times does 2 go into 3 evenly. I can take out 2 x's evenly, okay? So that means I can take out one whole x and I'm still going to have one left inside. So I'm going to have an x with an x under the radical left. Now with my y to the 8th, 2 goes into 8 4 times evenly, so I have x to the 4th left. The other way that you could do this might be a little confusing. If you have x to the 3rd, you could split it up into square root of x squared times the square root of x. So you know that the square root of x squared is just x, and then you can't take the square root of x. So that's kind of where this quantity came from. Okay, now that we have all of this left, everything that is not under the radical is going to go out in front. So I've got a 3, I've got an x, and I've got an x, or this should have been a y, sorry about that, and a y to the 4th. So I've got a 3, an x, and a y to the 4th. And then left under the radical, I've got a 3, and I've got an x. Okay, that might have been a little confusing, but I think as you get going, you'll be okay. So this quotient property now we're going to look at says that for any real numbers a and b, the square root of a over b is equal to the square root of a divided by the square root of b. So we've kind of talked about this. If you have the square root of 36 over 4, you could simplify the fraction and it's the square root of 9, which is 3. Or you could split it up as the square root of 36 over the square root of 4, which is 6 divided by 2, which is 3. So those are the same thing. Whichever one is easier to solve is fine. So let's look at this. Okay, so 5 over 4 does not simplify. So I'm going to split it up into the square root of 5 over the square root of 4. I can't simplify the square root of 5 anymore, so I'm going to leave it. The square root of 4, however, I can make 2. That is done because one of our rules at the beginning said that you can't have any radicals in a denominator, and we were able to get rid of a radical in the denominator, so we're good with that one. Okay, so on this next one, I'm actually going to simplify the fraction first. Because I have 3 m's on top and 1 on the bottom, I know I have, now I can take that away, and I have m squared on top and no m's on the bottom. So now the square root of m squared is just m, and the square root of 9 is 3. Okay, try the next one. So when I take, you can check, but 25 and 108, they're not going to simplify. So I'm going to rewrite this as the square root of 108 over the square root of 25. The square root of 108, okay, you want to check, are there any, what's the biggest perfect square that goes into it? So of those ones, 4, 9, 16, 25, 36, 49, and so on. If you were to check, 36 goes into this 3 times. So I can split 108 up into 36 and 3. And then I still have the square root of 25. Now I can simplify the square root of 36 and make it just 6. The square root of 3 stays, and my bottom, the square root of 25, becomes 5. Okay? Again, we're good because there's no square root in the denominator. Okay, so on this next one, 36, sorry, I'm looking at the wrong one. 9x cubed over 16. Okay, I'm going to split this up into the square root of 9 times the square root of x to the 3rd, all over the square root of 16. Okay, the square root of 9 is 3. Now, because I have 3 here, I want to figure out how many groups of 2 can I pull out of 3. Well, I can pull out one whole group of 2, and then I'm going to have 1x left under the radical sign. And then the square root of 16 is 4. Okay? Again, the other way I said you guys could look at it is like if you have the square root of x to the 3rd, you can split that up into as many squares as you can, because x squared times x equals x to the 3rd. So now that becomes just x, and you're left with the square root of x under the radical. Okay? Or you can figure out, since it's a square root, what is the most groups of 2 that go into that exponent on the variable. But this is our answer right here. Okay, let's try these next two. If you guys want to pause and see if you can get them, that'd be great. Okay, 12 over 27. If you can simplify the fraction first, do it. And we can in this case. 3 goes into 12 4 times, and 3 goes into 27 9 times. So now I have the square root of 4 over the square root of 9, which is equal to 2 over 3. Okay? On this next one, I'm going to rewrite this as the square root of 36 over, I'm going to rewrite this as the square root of x squared and the square root of x squared, because the square root of x squared times the square root of x squared is the square root of x to the fourth. So now the square root of 36 is 6. The square root of x squared is x. The square root of x squared is x. So I have x times x, which is 6 over x squared. If you didn't want to separate it like this and you just want to think how many groups of 2 can I evenly take out of x to the fourth, meaning I can take two groups out of x to the fourth, that's how I had 2 left here. And I can help you guys on that concept. I know that one's a little tricky. Okay, let's try a word problem, and then we've got just some lesson quiz problems, and we're good to go. A quad on a college campus is a square with sides of 25 yards on both sides. If a student takes a shortcut across the lawn, okay, how far does he walk? Give the expression in simplified radical form. All right, so in order to solve this, we need the Pythagorean theorem. So if you guys don't forget, the Pythagorean theorem says a squared plus b squared equals c squared. So now my c is always the diagonal, the hypotenuse of the triangle, and that we don't know. But we know our a and b. So I'm going to plug 25 squared in plus 25 squared in is equal to c squared, okay? So 25 squared is 625 plus 625 is equal to c squared. I'm going to continue this on the next one. 625 plus 625 becomes 1250. Now, sorry, I already drew this. In order to get the c by itself, I need to take the square root of 1250. However, there is no perfect square root of 1250, but you can split this up into the square root of 625 times the square root of 2. And then the square root of 625 is 25, and we leave the 2 under the radical. So your answer should be 25 radical 2 feet. Okay? Let's try these lessons. So go ahead and pause and just try these lesson quizzes, see if you guys are on the right track. And then I'll go ahead and do them. All right, so 31 plus 5 under the radical becomes the square root of 36, which is 6. This one I need to split up into x plus 25 times x plus 25. Or sorry, x plus 5, I should say. X plus 5 times x plus 5, which is the same thing as square root of x plus 5 all squared, which gets rid of one of the squares. Now, I didn't show you this on the other one, but we should technically say that we want it to be only positive numbers. So we should say that it's the absolute value of x plus 5. If you didn't do that, I'm not too worried about it at this point. We'll get to that. Okay, square root of 50. We can rewrite this as the square root of 25 times the square root of 2, which becomes 5 radical 2, because the square root of 25 is 5. Okay, 28 and 81. I can rewrite this. There's nothing that goes perfectly into either of these, so I'm going to rewrite this as the square root of 7 times the square root of 4 and the square root of 81. Now, the square root of 4 is 2. The square root of 7 I can't do anything with, and the square root of 81 is 9, so my answer is done. Okay, since it's a square root, how many perfect groups of 2 can I pull out of 3? I can pull one a out, and I'm still going to have an a left inside. With the b, I can pull out 2 groups, okay, because I can do 2 and 2, which makes 4. So that means 2 groups of b, but I'm still left with 1 b underneath because I only pulled out 4 b's. I still have another b underneath. All right, 27 and 48. We can simplify this. We can divide both by 3. 3 goes into 27 9 times, so we have 9x to the third underneath. And then 3 goes into 48 16 times. So now the square root of 9x to the third. Okay, I can pull a 3 out, and I can pull one x out since it's a square root, but I have an x still underneath, and then the square root of 16 is 4. Okay, so that's all for this lesson right now. I think you guys are probably going to have questions on the variable part. So just kind of look at some of these again and see if you can figure it out, and I'll answer any questions you